Hello and welcome to the Caterpillar Case Competition. We're Team 9. My name is Nathan and the other members of our group are Curtis, Maggie, and Lauren. To start off, we'll first discuss our strategy and objective, and then discuss our transportation model and some of the limitations that occurred. And then we'll discuss our potential strategies and some of the risks that are involved with this strategy. To start off, in disruptions in service is caused by the drastic change of our transportation decisions. Next, we must make sure our model fits globally, not just regionally. In terms of managing constraints, the model must be compatible with the lead time and hub and spoke capacity while trying to minimize costs. And finally, the model must make decisions in terms of flexibility and efficiency. Now we'll discuss our overall strategy for the model. We first developed our mode analysis by looking at the transportation costs and inventory costs. Next, we developed our model and underwent risk analysis by discussing our limitations and then implementing our strategy. Now I'll turn it off to Curtis, who will discuss our transportation model.
All right, thank you, Nathan. So I'm going to talk a little bit about how we made the transportation model. So first, I'm going to talk about our method. So the first thing we noticed when we looked at the data was that the shipping cost only was determined by the weight that we were shipping, not by the miles gone or the amount of trips that we're taking with either an airplane or a truck. So what we did was that we saw that the total weight to a spoke is not going to change. We have the forecasted demand, so the total weight's never going to change. So the making more trips won't really impact our total cost. So what we did was we looked at the lead time for surface and air, and we determined how much inventory we'd have to keep based off the lead times and how much safety stock we'd have to keep based off service levels. And then we wanted to compare the carrying costs, which will obviously be higher for surface because we'll be holding more inventory versus air, which can get there quicker, to the transportation cost, which is obviously higher for air versus surface. So once we're going to compare those two, and then we'll make a final decision on which is the total cheaper method. So a little example here, we're going to do this for every part going to every different store. So we're going to start with part 1 going to store 86. The transportation cost is calculated like I talked about, the forecasted sales times the kilograms per part, and then we had to look at the cost of the mode of transportation, so we did it both for air and surface. We also then calculated the inventory based off the lead time times the forecasted daily sales, looked at safety stock, like I talked about, from service levels and lead time, and then calculated the holding costs. We're using average inventory and safety stock times 12 months times the rate of holding and the cost of capital. So as a result, we're going to compare the surface transportation cost, which would be low, versus the air versus the surface holding cost, which would be high, versus air transportation cost, which would be low or high, and air holding cost, which would be low. Excuse me. So in this case, store 86 should get part 1 delivered via surface, which tells us that it is not a high volume product, and so there's not going to be a lot of holding costs. Next, I have just an example, a little screenshot of our Excel document. As you can see on my left here, the recommended method will tell us for each different part to each different store if it should use air or surface. And I have the highlighted up here. The top row is just part 1 to store 86, like I talked about earlier. So next I'm going to talk a little bit about the limitations of models, which I already hit on a little bit. So first, the cost of shipping. I talked about this, and this was a major driver for really all that we did. We saw that the data is just reliant on the weight we're sending to the spokes, which didn't make a ton of sense to us. So shipping 50 1-kilogram parts separately would be the exact same price as shipping one shipment of 50 kilograms. And we don't think that that's really accurate of how shipping in the real world works. We also noticed that the central hub has the exact same carrying cost as all the different spokes. So in this scenario, it wouldn't really make a lot of sense to hold inventory at the hub where we could just hold it at the spokes for the exact same carrying cost. So next I'm going to talk a little bit about truckloads, which ties into what I just said about the hub. So first, shipping costs. So shipping costs would change dramatically based on the full truckload or not full truckload, and this was not factored into the data we were given earlier. Also, the inventory amount. Since transportation would not factor based solely on weight, if we factored in truckloads, we would ship less often, which would make us hold more inventory. And finally, the hub, which I already talked about. The central hub would hold more stock if we were focused more on truckloads, because we would send a full truckload to the hub and then wait there until we had enough stock of one part to go to one spoke, so we could send a full truckload there. So we'd definitely be holding more inventory at the hub and more safety stock at the hub. So frequency of the analysis, you need to update this every single time we change forecast or every time we change cost. This model would need to be updated. But updating the model would be very efficient. We just put in the new cost and the new forecast and then be able to update it. So next, I'm going to pass it on to Lauren, who's going to talk a little bit more about our change management.
Thank you, Curtis. This model is going to change the way that dealers make decisions about transportation. And one of the issues we see coming out of that is service disruptions. When you're changing the transportation mode of a part, you're going to encounter certain factors like a changing lead time, additional regulations, and even new capacity requirements. And when dealers are making that transition, we want to make sure that they have the necessary support from CAT to implement those. And we want to make sure that the benefits of the tool have been communicated to the dealer before implementation so that they understand the future benefits of the tool even when they're experiencing these initial frustrations. Additionally, we want to make sure that CAT supports some emergency shipments. There are going to be certain disruptions that really are outside the dealer's control, and even though they usually cover those costs, we think in certain situations CAT should. We envision about 18,000 parts changing mode of transportation, and that's going to affect the overall network and its constraints. So some of the things we think need to be reconsidered or expanded is storage capacity, particularly at the spoke stores. Additionally, we'll need to acquire a larger fleet of airplanes especially, as the amount of air shipments is going to increase greatly. And finally, we may need to increase labor at the spoke stores as there'll be more shipments to receive, unload, and put away. And even somebody to update the model frequently and make those changes. One other thing we wanted to build into the model is flexibility for other locations. And a couple of the things that you should look at when you're moving into a new location is first and foremost the infrastructure. There may be modes available in other regions like rail that we hadn't considered in our model, but that would be very easy to build in moving forward. Additionally, you'd want to build in certain legislation such as tariff, fees, taxes, even regulations into the transportation cost in the model. And finally, the entire distribution network might be structured differently, so we might want to consider options that we hadn't built into our model in this instance, like risk pooling, and that would be a pretty easy fix. So moving along, I just want to touch on a few other potential risks we identified. One key one would be dealer cooperation. As I mentioned, we have to make sure they understand the benefit of the tool and we assist in implementation so it's useful moving forward. As we mentioned, capacity requirements will likely need to be increased, and that's going to be a pretty big undertaking that should be accomplished before implementation. And finally, although we want to update the model frequently to see those changes, we might not want to change mode every time it tells us to, just in case you're creating more chaos in the system than is needed. Now I'm going to hand it off to Maggie to talk about future transparency.
So the last thing that we want to touch on is the transparency that we think Caterpillar should uphold throughout this entire process, not just as it implements it in Latin America, but potentially throughout the entire globe. So one thing that Caterpillar does pride itself on is being transparent not just with its end consumers, but with the people that it deals with in its supply chain, including the dealers at this hub and spoke model. So the three things that we really want to touch on when communicating with these dealers is reminding them that this is just a recommended tool that they can use in order to switch modes as they see fit, and to stress that this could potentially reduce overall costs for them. But also something to really touch on is just the fact that it's going to have fewer surface shipments, and that'll be big just because, as Lauren mentioned, there are over 18,000 shipments that will be changing mode. So as obviously there's going to be fewer surface shipments, there's going to be a lot more air shipments that will result in lower lead times and holding costs, and that'll just be important to them because it will be a big change for them. And lastly, we just want to really push that this is going to be used for demand that is forecasted and fairly stable throughout the year. We mentioned having emergency shipments for potentially unstable demand, and that could potentially be covered by Caterpillar. So if not, it should just be used for that stable demand. Other things that they really should focus on in terms of transparency is keeping that open communication, as I mentioned before, but also determining other hub and spoke models that could, or locations that could replicate this model, and then beginning to track price per kilometer as opposed to just the weight, because I do think that this would have a big change on the costs of each of the modes, and this could change the data overall. And then the last thing that we want to touch on is just potentially removing that hub location, simply because the carrying cost is the same there as it was at all of the spoke locations, and it didn't seem extremely beneficial to be carrying a lot of inventory outside the regulated demand. So with that, we just want to thank you for the time that you took to listen to us, and we appreciate any feedback.